Welcome, my students. Our lesson today about the relation between inscribed angles and central angles. We have studied before the central angle BMC is called central angle because it's the vertex on the circle, on the center of the circle, and the two sides are two radii in the circle. What is the inscribed angle? Inscribed angle is an angle whose vertex lies on the circle and the two sides are two chords in the circle, such that angle BAC. Now we have two types of angles. Number one, central angle BMC and inscribed angle BAC. And we have studied before the arc such that BC. This arc BC opposite to the central angle M. And this arc BC in the same time opposite to inscribed angle BAC. Then we can say the inscribed angle and the central angle subtended to the same arc BC. Again, the inscribed angle A and the central angle M subtended to the same arc BC. What is the relation between inscribed and central angle if they are subtended to the same arc? Measure of inscribed angle A equal half measure of the central angle M. The first relation, the measure of inscribed angle equal half the measure of the central angle under condition they are subtended to the same arc in the circle. Okay? We have studied before the measure of the arc equal the measure of the opposite central angle. Then we can deduce that the measure of inscribed angle A equal also have measure of the arc BC. Then now we have two relations. Number one, the measure of inscribed angle equal half the measure of the central angle. They are subtended to the same arc, and the measure of the inscribed angle equal half the measure of the opposite arc. Okay? Let's go to the next theorem. The next theorem says if we have inscribed angles, two inscribed angles, three or more, but they are subtended by the same arc, XY. Now, in this figure, we have three inscribed angles, XAY, XBY, and XCY. They are subtended to the same arc XY. Okay? Now, we have the relation between all inscribed angles subtended to the same arc. We can say measure of angle A equals measure of angle B equal measure of angle C. Why? Because they are inscribed angles and subtended to the same arc XY. All inscribed angles subtended to the same arc in the same circle or congruous circles are equal in measure. Let's go the last point in this lesson. Now, in this circle M, If we have AB is a diameter in the circle M, then angle ACB is an inscribed angle. Angle ADB also inscribed angle, but this is inscribed angle drawn on semicircle, or we can say that drawn on the diameter ACB, this inscribed angle drawn on the semicircle or drawn on the diameter AB, and also angle ADB drawn on semicircle or drawn on the diameter AB. In this case, we can say measure of angle C equals 90 degree, and the measure of angle D equals 90 degree. Why? Because the inscribed angle drawn in semicircle is right angle. In another method, inscribed angle drawn on a diameter is a right angle. So we can deduce that measure of angle C equals 9 degree and the measure of angle D equals 90 degree. Now let's go to examples of this lesson. Number 1. Look at this figure given. The arc AD equals the arc BD. AD arc equals BD arc. Measure of angle CAB equals 50 degree. AB is a diameter in the circle M. The required find measure of angle CBD. The required find the measure of angle CBD. Okay, this angle CBD consists of two angles. CBA, we can name it number 1, and the second ABD number 2. Now we have two angles, angle 1 and angle 2. To find the measure of angle CBD, we must find measure of angle 1 and measure angle 2, and last find the sum of the two angles. Now, how can we find the measure of angle 1? We have AB is the diameter, okay? And the angle BCA is an inscribed angle drawn in semicircle or on diameter AB. Then we can deduce that since AB is a diameter and angle ACB is inscribed angle, therefore measure of angle C equals 90 degree. Okay, in the triangle ACB, since measure of angle CAB equals 50 degree, therefore measure of angle 1 equal 180 minus 180 minus 90 plus 50 equals 40 degree. Then we found the measure of angle 1 equal 40 degree. In the second triangle ADB, we have the arc AD equals the arc BD. We can deduce that the chord ED equals the chord BD, then this triangle ADB is isosceles triangle. Since arc AD, measure of arc AD equals measure of arc BD, therefore AD equals BD. The chord AD equals the chord BD. Now we can say the triangle ABD is isosceles triangle, since measure of angle D is 90 degree, because inscribed angle drawn in same circle, the same of the first case. Therefore measure of angle 2 equals 180 minus 90 divided by 2 equals 45 degree. Now we have the measure of angle 1 equals 40 and the measure of angle 2 equals 45 degree. Last, measure of angle CBD equals measure number 1 40 plus measure number 2 45 equals 85 degree. Now we have finished the first example. Number 2, in the opposite figure given chord AC equal chord AB, prove that measure angle 1 equals measure angle 2. Proof. Since AB equals AC, therefore measure of arc equal measure of arc. Same symbols, measure arc AB equal measure arc AC. Now we proved that the arc AC equal the arc AB. Okay. Angle 1 is describe the angle subtended to the arc AC, and the angle 2 describe the angle subtended to the arc AB. Okay. Angle 1 is an described angle subtended to the arc AC. Okay, and the same case, angle 2 subtended to arc AB. Since AB equals arc AC, therefore measure angle 1 equals measure angle 2, because they are subtended to equal arcs. Okay, angle 1 and angle 2 subtended to equal arcs, then they are equal in measure. Goodbye, with me in the next video.